Hello everyone. So this is the last our segment volumetric analysis. So here that first we'll try to understand equivalent weight of any element or that substance. See that by giving 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine, how much you are getting other substance or other element, that is only called its equivalent mass. Like suppose for example, if zinc is there and zinc combining with H2 and forming ZnH2, forming ZnH2. So zinc mass is 65 and this is here 2 gram of hydrogen either added or replaced. So you can see that 1 gram of hydrogen, how much in that zinc will be? 65.65 by 2 gram of zinc. So this is only equivalent mass of zinc with respect to either 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. So like that we can define equivalent mass of any substance. So you can see here that gram atomic mass we are dividing by some number. This number is only called n factor. So if we come to know how to calculate any substance or element n factor, very easily we can calculate equivalent weight of any substance, right? So here you can see equivalent weight is equal to gram atomic mass or gram molecular mass or gram formula mass divided by that number is n factor. N factor is always calculated for 1 mole of the substance. N factor also depends on the nature of the substance. Like here you can see H2C2O4 and FeC2O4. This is oxalate. So here you can see that if it is behaving as acid, means it can furnish maximum 2H plus. So its N factor is 2. But when it is behaving as a reducing agent, means it can reduce other and oxidize itself. So here carbon is plus 3, here also carbon is plus 3 oxidation number and iron is plus 2. So iron can go to plus 2 to plus 3 and carbon can go plus 3 to plus 4 maximum. So change will be how much? Plus 3 to plus 4, 1. And total how many carbons such like that? 4. So 1 into 4, 4, and along with iron is plus 2 to plus 3. So again from iron it is coming 1. So total it is 4 plus 1, 5. So for same substance you can see its nature depends on nature. Behaving as a acid, N factor is 2, and behaving as a reducing agent, N factor is 5. N factor also depends on types of reaction. Like suppose for example H2SO4, if it is reacting with 1 mole of NaOH, so it will furnish only 1 H plus. So N factor will be 1. But if it is reacting with 2 mole of NaOH, then it can furnish 2 H plus. So N factor will be 2. N factor for any substance depends on the reaction. It could be positive also, 0 also, fractional also, but not negative. If it will be negative, you know that equivalent mass will be also, equivalent mass is never negative. Any substance mass could not be negative. So N factor also is not negative. N factor will be variable. Understood? Like here we discuss N factor is variable. So if N factor is variable, equivalent mass also, equivalent mass or equivalent weight also will be variable. Next point, equivalent weight. Equivalent weight, it could be greater than or less than gram atomic mass or gram molecular mass or gram formula mass. Like suppose N factor if it is fractional, means if it is 2 by 3 less than 1, then equivalent mass will be greater than gram atomic mass or gram formula mass or gram molecular mass. But generally what happen, N factor is like 1, 2 like that. So if it is 1, 2, 3 like that, so that time equivalent weight will be less than gram atomic mass, gram molecular mass or gram formula mass. But whenever N factor if it is fractional, that time equivalent weight will be greater than gram atomic mass or molecular mass. So now if we know how to calculate N factor, very easily we can calculate equivalent mass of the substance. So here n factor we will calculate by A for acidity. For bases we will calculate acidity is called its n factor. For acid we will calculate basicity. By basicity is only called n factor for acid. Then after A, B, C for charge, whatever the charge having that whatever magnitude, that is only called its n factor. And then after fourth one is A, B, C, and then after V means valency. So whatever the valency of element will be there, that is called its n factor. So let's start first A. A is acidity, is defined for base. So per mole of base, how much OH minus it is furnishing, minus here there, so how much it is furnishing, that is called its acidity, and that is called its n factor. Or second definition, it could be that per mole of base, how much H plus it is accepting, or how much due to its presence per mole of base, how much H plus is replaced, that is also called n factor. Like for example, here you can see Na2O reacting with H2SO3. So due to its presence it cannot furnish OH minus. Yes, but due to its presence you can see 2H plus is removed. SO3 here it is combining with sodium. So its n factor is 2. Per mole due to its presence, how much mole of hydrogen is removed? You can see that is only called its n factor. Here you can see calcium hydroxide reacting with 1 mole of HCl and 2 mole of HCl. So when it is reacting with 1 mole of HCl, so it will furnish only 1 OH minus. Clear? And here calcium hydroxy chloride is formed. So here n factor is 1 with respect to 1 mole of HCl. But if it is reacting with 2 mole of HCl, then its n factor is 2. So for same substance, n factor is variable, depends on different reaction. If n factor is variable, its equivalent weight also is variable. Here you can see magnesium oxide. Due to its presence, how much hydrogen is removed? 6H plus is removed. Here you can see phosphate combining directly with magnesium. So 6H plus is removed by 3 mole, but n factor defined for 1 mole. So here 6 divided by 3, n factor for MgO is 2. Here you can see sodium bicarbonate. Sodium bicarbonate is also base. So for this acidity will be, how much H plus is removed? 2. Per mole how much? 2 by 2, 1. Clear? So now second we will discuss B. B means basicity. Basicity defined for acid. So per mole of acid, how much H plus is furnished is called its n factor. Or per mole of acid, how much OH it is accepting, or due to its per mole acid presence, how much OH is replaced in from other substance, that is also called its n factor. H3BO3 boric acid is there. So you can see that it cannot release H plus, but due to presence of water, since it is Lewis acid and water can behave as a Lewis base, so it is giving its lone pair to boron. So it is accepting 1 OH minus, and this H plus is coming from water. So overall boric acid having how much n factor? 1. Here you can see phosphoric acid, it can furnish 1H plus, 2H plus and 3H plus because it having 3 acidic hydrogen. So its basicity depends on the reaction 1 to 3. If it is not given, we will consider 3. Here you can see this is phosphorus acid. So phosphorus acid, in that you can see that it can furnish 2 hydrogen. So 1 and 2. Whereas hypophosphorus acid, it having only 1 acidic hydrogen. So its basicity is 1. Here very one remarkable point, even though its basicity is 1, but its acidic strength is more as compared to phosphorus acid and phosphoric acid. Okay, already I discussed in classes due to presence of minus I effect. Here minus I effect is very impactful. Now here you can see non-metal oxides are also acidic. So due to its presence, how many OH is removed? 2. So n factor will be 2. Here that ammonium salts are also basic in nature. So due to that, how many OH is removed? Due to its presence, 1. So its N factor per mole is 1. Now coming charge. So in charge, three segment we will study. First, that those ions which is there in either cation or anionic form. So per mole, whatever they are having charge, that is only called their N factor. Of course, here it is minus, so we'll apply mod so that N factor will be positive. Now coming to second segment, that salt which neither going for oxidation nor going for reduction, means those substances which oxidation number not changing throughout. So for that, N factor will be total charge on cation or either total charge on anion. So here you can see AX BY. So you can break this one. So by crisscross, AY plus and BX minus, and by conservation of atom also, that total A is X. So X AY plus and total B is Y. So YB minus X. So total charge on either cation how much? X into Y. Total charge on anion how much? Y into X, means XY. Except when X and Y in binary compound, if it is 1, that time you have to break compounds. Otherwise you can just do shortcut X into Y. So here if you do 1 into 1, 1 into 1 means N factor will be 1, but that is wrong. So whenever X and Y is 1, that time you have to break properly, and then it will form, here it is forming through crisscross, Al plus 3 and N minus 3. So N factor for this substance is 3, means molecular mass of this substance divided by 3 is called its equivalent weight. Here we can also apply equivalence. Equivalence of this compound is equal to equivalence of this cation plus equivalence of this anion. So since it is breaking and this is its internal part, so here we will apply plus. But in chemical reaction like A reacting with B and forming C and D, there we will apply equivalence of A is equal to equivalence of B is equal to equivalence of C is equal to equivalence of D. That is law of equivalence without balancing. Already underground it is balanced. So here also we are applying equivalence, but since from this both are the part of this, so here we will apply plus. Then only its equivalence is equal to its equivalence right hand side. Clear? So here you can see its molecular mass divided by N factor X and Y. Here its molecular mass divided by N factor is charge. No need to bother about stoichiometric coefficient. Here also molecular mass divided by its charge. That is the N factor. Third one, you can see equivalent weight of oxidizing agent or reducing agent. Means those salt which oxidation number is changing. So whatever the change in oxidation number into that element whose that N factor we are calculating into its number of atom, total number of atom, that is only called its N factor. Or either we can say total number of electron loosed or gained by 1 mole of that substance. Like here you can see such, for example, Mn, here in this MnO4 minus 1, so manganese is here plus 7, in acidic medium H plus is going to Mn plus 2, Mn plus 2. So here for balancing, manganese already valence, oxygen here 4 oxygen valence. So for balancing hydrogen 4 to the 8 H plus I balanced here. So now you can see total how much. So here it is 8 H plus means 8 proton and here 1 electron. So total overall 7 proton left hand side. Right hand side only 2 proton is there. So what I will do, this side I will add 5 electron. Is that clear? So due to that 5 electron, what happening? It's reduction happening. And N factor, how much oxidation? Change in oxidation number plus 7 to plus 5 means change in oxidation number is 5 into how many atoms? This one for which we are calculating 1. So 5 into 1, its N factor is 5 in acidic medium, right? So here this is. Now moving further, so here you can see MnO4, very important this one. If in acidic medium, so its N factor will be plus 2. If it is going in basic medium or a strongly alkaline medium, so it is going to plus 6. So change in oxidation number 1 into atomicity 1, so n factor is 1. Or ideally faintly alkaline or neutral medium, it will go to plus 4, so change in oxidation number 3 into atomicity 1, so n factor is 3. You can remember this trick also. Ban 153, in basic medium 1, in acidic medium 5, in neutral medium 3. If medium is not mentioned, consider acidic medium. Now coming to dicarbonates. So dicarbonates in acidic medium, always it will go to plus 3. So how much? Plus 6 to plus 3, n factor is that change in oxidation number 3 into atomicity 2. So n factor is 6. But that bicarbonate, that this one Cr2O7, this dicarbonate in basic medium it is unstable and it will go to chromate. So dichromate will go to chromate in basic medium, means overall here it is plus 6, here also plus 6. So change in oxidation number 0. The overall n factor will be 0, means this is neither oxidation nor reduction. So remember this one. Similarly here you can see chromate. So chromate in acidic medium, like here it is going in basic medium. So chromate in acidic medium is unstable and it will go to dichromate. So again here also it is plus 6. So n factor is 0, neither oxidation nor reduction. But that same chromate in basic medium, like here it in basic medium it was going plus 6 to plus 6, but here it will go in basic medium plus 6 to plus 3. So n factor is 3. So here trick also you remember ABCD. In acidic medium chromate and in basic medium dichromate. N factor is 0, means neither oxidation nor reduction. In D block we will study their colors and all everything. Now here some important reducing agents also, like here you can see oxalate, oxalic acid. So here oxalic acid, that carbon is plus 3, always will go to plus 4, only one possibility there. So change in oxidation number 1 into atomicity 2. So n factor is 2. Here you can see that hypo solution Na2S2O3 going to Na2S4O6. So already we know its oxidation state is plus 2 and its oxidation state is 2.5. So change in oxidation number, oxidation state or oxidation number into its atomicity. So total how much? 0.5 into 2, 1. Means its n factor overall for this molecule is 1. Because alkali will not change, oxygen is not changing, only sulfur can change. Plus 2 to 2.5, means behaving as a reducing agent, reduces other, oxidizes itself. Now the fourth one we will discuss, that is valency. So valency, whatever the valency of element is there, that is only called its n factor. So for metal, valency is number of valence electron. For non-metal, that valency is number of 8 minus number of valence electron. So chlorine having 7 valence electron, so 8 minus 7 is its valency. So that is only n factor. Now here some set of questions we will do and we'll understand how to calculate n factor for both reactant and product. So here you can see HNO3 going to NH4NO3. So here also nitrate, here also nitrate. So with respect to this nitrogen, if we'll do, n factor will be 0. But with respect to this nitrogen, plus 5 going to minus 3. So overall difference is minus 8, means 8 into atomicity is 1. So n factor for this it is 8. Whereas this one also difference is 8 and atomicity is 1. So n factor is 8. Here you can see mixed oxide, ferriferro oxide. So here oxidation state is plus 3. Here oxidation number is plus 3, or oxidation state also plus 3. So change in oxidation state into atomicity. So its n factor is 1. Here also change in oxidation state into atomicity. So this is its n factor. Here you can see non-stoichiometric oxides. So here it is, its oxidation number, oxidation state is 200 by 93. And here it is plus 3. So change in oxidation state into atomicity. That is its n factor. Here also change in oxidation state into its atomicity, that is its n factor. Here you can see this is pyrite. So here sulfur is -1, like per oxy linkage, like that here thionic linkage is there. So here that -1 going to +6. So overall difference is 7 into atomicity 2. So n factor is 14. Now coming to second set, when in reactant or product, if more than one elements are getting oxidized or reduced, then how to calculate oxidation number? Like here you can see FeS2, in that iron +2 is going to +3 and sulfur -1 is going to +6. So very simple, you calculate with respect to iron, it is change in oxidation number into atomicity is 1, and sulfur is going -1 to 6. So 7 into its atomicity 2. So overall sum, overall for this molecule, n factor is 15. Similarly here +2 and +3, difference is 1 into atomicity 2. So n factor is 2. +6 going to -1, or -1 coming to +6. So difference is 7 into atomicity 1, n factor is 7. Here you can see cyanide. So in cyanide, carbon triple bond and carbon having negative. So in carbon and nitrogen, which one is more electronegative? Nitrogen. Bonding method. So here it will be -3 and here it will be +3. So overall carbon having +3 and -1, +2, and nitrogen having -3 in cyanide oxidation number. And in isocyanide, nitrogen having -1, since here it is -3 and carbon will have +3. So overall nitrogen is -3 and -1, -4, and carbon is +3 in isocyanide. So whenever such type of compounds coming, be careful while calculating. First you represent carbon and nitrogen in left side, and then after you see respectively in right hand side, and accordingly you calculate change in oxidation number into atomicity. Here some example, as we in starting we discussed oxalate containing compounds. So here you can see H2C2O4, Na2C2O4. So if it is behaving as a acid, so it can furnish only H+. So with respect to that, n factor is 2. And if it is behaving as a reducing agent, so hydrogen cannot reduce. Yes, carbon +3 can go to +4. Means reducing agent means reduces other and oxidizes itself. So here it can oxidize +3 to +4. Sodium already +1 is there. So its oxidation number cannot change. Alkali metal is always +1. Alkaline earth metal is always +2. Fluorine is always -1. Already we discussed. Oxygen range is -2 to +2. Clear? So this all those. So here change in how much? It is +3 going to +4. So total it is 4. Total how many carbon here? 4. So overall n factor is change in oxidation number into atomicity. So total atoms are 4. Change in oxidation number is 1. So according to that, n factor is 4. Now coming to disproportion reaction. So for disproportion reaction, n factor we can calculate. Already we discussed in class with general equation. So it will be number n that with respect to oxidation, with respect to reduction, divided by n of oxidation plus n of reduction. For example, here you can understand I2 going to I minus and IO3 -1. We discuss when in basic medium, when it is hot and concentrated. So here you can see n factor. How to calculate? With respect to oxidation. So oxidation how much? 0 to 5. So how much difference? Change in oxidation number 5 into atomicity 2. So 5 into 2, that is NO. NR is what? 0 to -1. So difference is 1 into atomicity 2 divided by NO plus NR. So here it is 2 and here it is 10. 10 plus 2. So overall 5/3 is the n factor. Law of equivalence, you know that whenever any reaction is unbalanced or if it is balanced, no need to worry about their stoichiometric coefficient, because indirectly in that stoichiometric coefficient is there in term of number of moles into n factor. Clear? So here equivalence of A is equal to equivalence of B is equal to equivalence of C is equal to equivalence of D. Already in concentration term we discussed that equivalence, gram equivalent of any substance, we can calculate normality into volume, whereas normality is number of molarity into n factor. So overall molarity into volume is number of moles into n factor. So further from here, that next segment we will do, that is titration. So till here I am stopping, and after that next segment we will start titration, where we will discuss 5 type of titration: acid base titration, redox titration, back titration, double titration, and iodometric and ideometric titration. And then after our topic 100% synopsis completed, which is quick revision, which is giving you power to solve any questions. So in very limited time you are revising all those topics crisp gist form, which will help you a lot sufficiently to solve any questions related to JEE Mains, Advanced and NEET. Thank you very much. Next topic we will do titration.